Alright, so this time we're going to talk about negative exponents. So we'll start by taking each of these values, and what I'm going to do is you've noticed that I've taken each value starting at 16 and cut it in half as I go down the column. So what I'm going to do is take each of these numbers and write them as a power with a base of 2. So we'll start out with 16. We know that 16 can be written as 2 to the 4. Oh, that's a little bit too high that you can't see it, so I'll write it as 2 to the 4. 8 is written as 2 to the 3. 4, of course, 4 is just 2 squared. 2 then can be written as 2 to the 1. And for the next one, so if I continue this pattern, these are being divided by 2 each time. And you might notice that these exponents, as I go down the column, are decreasing by 1 each time. So using the pattern, you could hypothesize that the next exponent then should be 0, which is true. Any base raised to the power 0, raised to the exponent 0, always equals 1. Now, if I continue this pattern past 1, well, I'm dividing each of these numbers by 2. So if I take 1 and I cut it in half again, my next number in the column should of course be 1/2. And the number after that, well, if I take a half and split it in half, so I've got, there's 1/2 represented right there. So if I take each of these pieces and cut it in half again, I end up with this split into quarters. So my next number is 1/4. And the next number down would be, if I take each of these and cut it in half again, I end up with this thing divided now into 8 pieces, so 1/8. And I'll stop there for now. So now, if I continue the pattern in the right column here, exponent 3, 2, 1, 0, you could hypothesize that my next exponent then should be -1. The exponent after that should be -2. And the exponent after that should be -3. And those are correct. So all a negative exponent really does is take the value that you have and really just put it in the denominator, right? So 2 to the 3 is 8, so 2 to the -3 is 1/8. 2 to the 2 is 4, so 2 to the -2 is 1/4. So in general, when I have a to the -m, that can be rewritten as 1/a to the m, no matter what a and m are. Okay, so let's look at a couple of examples using negative exponents now, and some of the things that we just covered. I'll leave that right there for now. So the first one, we'll start out really easy. So if I've got 4 to the -2, then in this case the 4 is the a, and the 2 is the m. So this should quite simply then become 1/4 squared. And then I can just find out that 4 squared is equal to 16. So this becomes 1/16. Okay. How about, though, if my exponent, instead of being a nice number like that, is a fraction? So let's say I have 8 to the -2/3. Well, the same property holds, so this should then become 1/8 to the 2/3. And then all I need to do is evaluate what this is here in my denominator. So 8 to the 2/3, remembering back to the last section, a fractional exponent represents a radical. So my denominator here becomes the index of the radical, so this is the cubed root of 8. And then I square that. Of course, the cubed root of 8 now is 2, because 2 times 2 times 2 gives me 8. So this becomes 2 squared, and then 2 squared is equal to 4. So this really just becomes 1 over 4. Let's look at maybe two more examples, actually. Two more. We'll ramp up the difficulty one more step. So let's say we've got 9 over 16, and we're going to raise that to a fractional exponent. So there are two ways to do this. There is a shortcut. I'm going to do it the long way first, and then show you the shortcut after. So having a negative exponent here means that this whole thing just ends up going in my denominator with a positive exponent. So this really is 1 over 9 over 16 to the positive 3 over 2. And now we can evaluate each of these pieces. Well, when I have something inside a bracket raised to an exponent, I put the exponent on each piece. So if I've got 9 over 16 to the 3 over 2, then what I'm going to do is write that as 9 to the 3 over 2 over 16 to the 3 over 2. And then evaluate these radicals. So 9 to the 3 over 2, well, denominator's 2, this means it's square root of 9. Numerator's 3, so exponent 3, over 16 square root, and then cube that. So the square root of 9 is, square root of 9 is 3, and I'm going to cube it. Square root of 16 is 4, and then I'm going to cube that. So my answer becomes 3 cubed, which is 27, or 4 cubed, which is 64. So my answer becomes 1 over 27 over 64. And this looks a little bit ugly, so we need to simplify this a little bit. Well, to divide fractions, you multiply by the reciprocal. So I could write this as 1 divided by 27 over 64, which then becomes, I would write this as 1 over 1, of course. To multiply, I would keep the first fraction the same, change the division to multiplication, and flip this fraction right here. So 27 over 64 becomes 64 over 27. Then 1 over 1 times 64 over 27. Well, to multiply fractions, you multiply your numerator by your numerator, and then your denominator by your denominator. So this would be 1 times 64, which is 64, and 1 times 27, which is 27. So my final answer becomes 64 over 27. Now that's the long way of doing it. There is a little bit of a shortcut, because what you might have noticed is really this last step here, all it really did is take the fraction that we had and flipped it. So it just took the 27 over 64 and flipped it to the 64 over 27. So if I know that in the end I just end up flipping the fraction anyway, then I can take a shortcut and just flip it right off the bat. So the second way to handle this is to say, okay, since my exponent's negative here, I'm going to end up flipping the fraction. So what I can do is take this one right here, 9 over 16, and right off the bat I flip it. What that would allow me to do then is to write this as a positive exponent, because flipping the fraction changes the sign of your exponent from negative to positive. Notice that the exponent's fraction doesn't flip, it only changes sign. So now all I have to do is evaluate this expression right here. And to do that, I would just say that is 16 to the 3 over 2 over 9 to the 3 over 2. And then I would evaluate 16 to the 3 over 2, which again is just the square root of 16 cubed over the square root of 9 cubed. And then evaluating this, I end up with the 64 over 27. That way. So instead of having to deal with the division of the fractions at the end, just flipping the fraction right up front allows me to bypass that step. I just wanted to show you the first way so that you understand really why that fraction ends up flipping. So let's do one more just to make sure that you feel comfortable with it. So the next one, we'll go through this one a little bit quicker. So it's negative 27 over 8 to the negative 2 over 3. So first of all, what I can do is, since this exponent is negative, is I flip the fraction that's in here. So this becomes negative 8 over 27. And now this is a positive 2 over 3 exponent. So now you might ask me how to deal with this negative value. Well, you could just leave it there and deal with it. Or what I usually do is take the negative and put it with either one of these numbers. So what I'll do, just for simplicity, is I'll take that negative number and I'll stick it with the 8. So then I'll have negative 8 over a positive 27. Because it doesn't matter which number I put the negative sign on, the whole fraction still ends up being negative exponent 2 over 3. So now what I'm going to do is put this exponent on both the numerator and the denominator. So this gives me negative 8 to the 2 over 3 over 27 to the 2 over 3. Cube root, since my denominator is 3, so this is cube root of negative 8. Numerator is 2, so square. Cube root of 27, and then square it. Well, the cube root of positive 8 is 2, so the cube root of negative 8 would be negative 2. Then I square it. Denominator, cube root of 27 is 3, then I square it. So negative 2 squared is negative 2 times negative 2. Well, this gives me a positive 4. And my denominator is 3 squared. So this gives me, I'll try to fit it up here, 4 over 9.